In this lesson, we're going to learn a new formula for the area of a triangle and then use that particular formula to come up with the law of sines. On the screen, I have a triangle ABC. I've intentionally placed side B, which is of course opposite angle B, as part of the horizontal. And really the reason for that is so that no matter where I move B and no matter how big I make A and vice versa, so something like this, you will always see that I can then just pretty much name this. B could stand for base. Why is that helpful, important? Well, the typical formula that we've learned is that A equals 1/2 base times height. And well, B can now stand for base. Well, to figure out my height, I'm going to show you my height right now. That is the green segment right here. And I actually realize that there's a relationship between this height right here and this angle C right here. The key part is, since there is a triangle, let me put this in this color and we'll make it thick. There's a triangle right here. That's right. I can use right triangle trigonometry and establish a pattern where A, the hypotenuse, and height, the opposite, can be put into a ratio that relates to angle C. And in fact, I could say that the sine of angle C could equal my opposite, or in this case H, over my hypotenuse A. Because I have this relationship, if I essentially multiply both sides by A sine of C could equal H. This will make a wonderful substitution into this formula. And it will produce a brand new formula that once I rearrange the variables, our new formula for an area of a triangle can be computed 1/2. I'll put the A first, I'll put our B second, and then I can put sine of C last. And this is our new formula for an area of a triangle. Not saying you can't use the old one, but here's a brand new one. What does this allow me to do? Essentially, you take any two sides of the triangle. Now, I'm not talking the right triangle. I'm talking from B down to C all the way over to A. As long as I have this angle in between there, I have enough information to figure this out. So I'm going to have, in this problem, I'm going to have this length be, let's make this, let's make it 4. And if I call this length 6, it's just random numbers right now, I would need an angle in this particular problem. So I'm just going to say that this angle may be 40 degrees. If I have all that information here, what I can do is plug it in my formula, say 1/2 equal, or 1/2 times, let's say my length is 4. Now, it really doesn't matter if A was 4 and B was 6, because in the end the multiplication is the same. 1/2 times 4 times 6 times the sine of 40 degrees. And if I work that out with my calculator, not really seeing my little multiplication symbols there. Come on, there we go. Typing it in, I get an area of 7.713 units squared. And there's the use of the new area of a triangle formula. Let's use the area of a triangle formula. We'll click on my button again to show me the height. And I will write down my formula given the fact that A equals 1/2 my one side A, my second side B, my angle C. I have my formula. But if I would change my perspective and I would say, now this is my base, this is my angle B, and I also am given side C, I could actually rewrite the same formula as 1/2 AC sine of b. I could even go as far as and change my perspective a third time, say this is my height to my base, therefore give an angle A and my two sides B and C, and I could actually write the formula again as 1/2 BC, seems to be slowing down a little bit, sine of A. In fact, I'm going to use this relationship that no matter which way I look at it, it's always the same area to develop my law of sines. So I'm going to clear the screen out. Hopefully this will improve my performance. And I'm just going to essentially write these all over again. I'm going to write A equals 1/2. I'm going to write BC sine of A first. We're having some interesting things occur. Sine of A. Then I'm going to write 1/2 AC sine of B. And then I'm going to write 1/2 AB sine of C. And what I would like to do is realize that since I have A here, in fact, let's just try erasing this a little bit, see how much I can erase. There we go. I don't really, oops, that was interesting. I could actually bring it back. I do not need my A in this problem, and I'll be left with all this. And then I realize I don't even need to have my half as well in either of these problems. I could multiply everything by 2 to drop it out, or I could divide by half, whatever you want. And I could be left with BC sine A equals AC sine B, which equals AB sine C. So, if I could have eliminated the halves, wouldn't it have been nice to eliminate, let's say, in each of these problems, A? Because this would have gone. This would have gone. Unfortunately, it would have left me an A in the denominator here. Of course, B would have been nice to be gone here because it could be gone here, but unfortunately it would not be gone there. And using that same kind of thought process, I could get rid of C in these two, but I can't get rid of C in this last one. The funny thing is, if I do all three of them, I actually get the law of sines, because when you eliminate B and C here, you get sine of A is to A. If you eliminate the A and C from these, you get sine of B is to B. If you eliminate A and B from here, sine of C is to C. And that is the law of sines. The key thing to understand about the law of sines is for it to work, you need the angle and a side opposite that angle to establish the fraction that then you can use to find other sides and angles. If you don't have that, you can't use the law of sines. We're going to show you how to apply the law of sines to other triangles in other videos.